All right, let's go to my schedule, and we're going to fork that program and go to Tuesday the 19th. And I don't know if you noticed, but I have bookmarks at the top to help you scroll a little bit. So if you go to click October, click on bookmark, should take you down to the first day in October. Then you have to scroll a little bit. That way you're not scrolling all the way down when we get to December. And we're going to fork this program right here. And we're starting while loops today. And the author introduces it before the official time today. So should be a little familiar with these loops. But today we'll actually start talking about them in more detail. Everybody there? All right, so the first thing we want to do, here's the output. We may refer to this, but I have it described here. Use a while loop for each part, first of all. That's what we're doing today. Print out the numbers 1 through 5. And I start out with the variable int run is equal to 0. So we're going to use run. So we'll say while run is less than 5. Let's put it in braces. By the way, if you don't, listen to me now, if you don't have braces, it only does the next line, just like an if statement. If statement only does the next line if you don't put braces in. So keep that in mind. There's one problem on the worksheet that I know of that's pretty tricky that you'll see it when you get there, hopefully. All right, what are we going to do? Well, I want 1 through 5, if you remember the output, so we better do run plus plus. We better add 1 to run because right now it's sitting at 0 and I don't want to print 0. If you look at the output, it's just 1 through 5. Now, I'm a little cautious that I might need an equal sign there. I may not. Let's find out. Now, the next line we're going to print. System, out, print line, actually print. And we're going to go run plus, and there's commas in there if you look at the output. And let's just run it, and this should just work. The rest of the program shouldn't have any errors. Oh, and it worked. So I did not need an equal sign for this because it'll increment 1, print out 1. Check it. 2, check it. 3, 4. When it becomes 5, it'll print out 5, and then it'll go up and check, and it will skip this. It will not go again. Once this becomes false, it does not run it. Once that becomes false, it skips over it, and it just proceeds to the next line after the brace. Go ahead.
Why did you use print instead of print line?
Oh, because of the output. See, right there. It kept it on the same line. All right, that's all.
Because if you did print line, it would do 1 and then do the next line.
Yeah, it'd go down the next line. It'd be vertical, which wouldn't be a big deal, but that's not what the output was. All right, infinite loops. Let's talk about infinite loops. And we can undo this. I'm going to take this out and this out. And we're going to run it, and what you're going to see is, I got a couple errors here. I need a semicolon here, and I missed out here. I commented it out and never ran it, so that's why I had errors in it. I should comment it out after I run it, would be a very smart idea. Now notice it's printing infinite over and over and over again. It's an infinite loop. Run is 6. Run is greater than 5. Yep, that's true. It prints it, but it never reduces run. It'll always be greater than 5. Now, even if I did this, check this out. If we stop it and we go, all right, I'll go run plus plus. This is still an infinite loop because I went the wrong direction. Yeah, run's adding on value, but it's the wrong way. We're going in the wrong direction. So we could fix this by going run minus minus, and then it only prints out it only prints out infinite one time, though, which is fine. But try to avoid infinite loops, and that's what can happen. The conditional is always true. You never stop. All right, that is infinite loop. Use a while loop to count down to 10 by 5s. And if I look at the output, I have 25 loop, 20 loop, 15 loop, 10 loop. So let's try to get this to work. I'm right here. So I'm on line 38 of the program. While run is greater than, and I might want, let's throw in, I think I want equals, I think. But if the output isn't correct, I can go take it out, and maybe it'll be right now. But I do want to start with 20. I want to go 25 to 10 by 5s. So let's go system out, print line, run, plus, we'll go escape sequence, new line, and type the word loop. And I could have done this with 2 lines also. I could have printed run and then printed loop. That would work too. All right, but now we want to reduce run by 5, minus equals 5. I think this, yeah, I feel good about this. Did I get the 10? I got the 10 also. But let's say you didn't know that you had equals, and I think this is fairly obvious. You run it. It only goes to 15 because it stops when it hits 10, because it won't do it. When it's equal to 10, it'll stop. It'll be false. Oh, I didn't get all the way down to 10. Throw an equal sign in there, and it works just fine. Accessing digits. Print each digit on a separate line. So print the 10s, or the 1s, the 10s, the 100s, and the 1000s on a separate line. Grabbing digits. You'll have to know this for your lab today. It could be on the test. It's kind of a topic that's fairly straightforward and is used a lot by AP. So we're going to go while, or at least by this author, I'll say at least that, while the number is greater than 0. Here's what we're going to do. And I have to think about this too. What are we doing? We're printing the last digit. So we're going to go system out, print line. How could I print the last digit? What do you think I'm going to put here? What is it? Mod 10. Yeah, we're going to go number mod 10. Very good. We've talked about some of this before. All right, so now that grabs 4 because the remainder is 4. Mod is remainder. But now I want to get rid of the 4. And if we do number divided by 10, it'll be 915, because remember it does integer division. It won't be 915.4. Only if we made them doubles. We would cast it as a double and we could get the decimal. But we're dividing by 10, that's integer division. And then why does it not like that? Insert, oh yeah, it's just running behind. Anyway, this should work. This should print out those numbers, 4519, 4519, and it works. So we're kicking off the 1s digit every time. We're modding it, kicking it out, modding it, kicking it out, modding it, kicking it out. So in this program, it doesn't matter how many numbers we could have. We could add 2 more and it's going to work, because it's looping until the number is 0. Once it takes that leading number, divides by 10, that 2 divided by 10 is 0 in integer division.
So would it be mod 10 like every time you do something like that?
If you want the last digit, that's right.
Okay.
Yep. If you want the last 2 digits, it'd be mod 100. All right, I have a challenge for you here. Add all the digits of the number. What if we wanted a running total? You're going to start on line 53 and print out the total. And the total for 1, 2, 3, 4 is 10. So your answer should be 10. Give that a try. What would that look like? Do you get bored in class?
No, one of my friends tried.
Okay, all right. What if we wanted to accumulate a total now? What would that look like? Let's wait about 30 seconds or so, and then we'll head out to lunch. I don't know if we'll be able to finish. I'll tell you what. Let's just finish this up, and we'll head to lunch. It's saved by the lunch bell. While number is greater than 0, now I need to accumulate a total. So total plus equals number mod 10. So that grabs the last digit and adds it. Now we just need number divided by 10. And that's it. That's all we needed. And the total should be 10 now. So grab it and then kick it out. Have a good lunch. We'll see you.
Have a good lunch.
Thank you. I'm going to stop this recording, then I'll go back to that. Is it on? Yep. All right. We're back. Next order of business is we have, we're going to trace some programs. Let me grab this. Download. Show folder. This is what you might typically see on the test. Tracing programs, giving output. But we have a program, and we have the variables and the output. So num1, it starts with 1. How come that's not writing? 1. And num2 starts with 40. And then it checks. While num is less than 8, that's true. Num2 is greater than 2, that's true. It'll do what's inside the braces, as long as that's true. So we're going to print num, so the output is 1. Num gets added 1 to it, becomes 2. 2 is divided by 2, so num2 becomes 20. And I think we're still both true. Less than 8, greater than 2, prints out 2. Then this goes to 3, this will go to 10, checks again. Both true, I think, still. Less than 8, greater than 2, this prints out 3 because it's printing out num, the value of num. This goes to 4, that goes to 5. Both are still true because it's greater than 2. Then it goes to 5. This goes to not 2.5, but 2. And it's kind of like in the middle of these, it goes pretty quick. But then when you get to the end, you got to slow down and see if it prints out 5 or doesn't print out 5. Because right now, num became 5, and num2 just became 2. So now it's going to come back around and check it. Num is still less than 8, but num now is not greater than 2. It's exactly 2. So 5 will not be printed. It's usually that last value that catches you, where you're either going to be right or wrong, that last value. It does not print 5. It stops. On this one, num is 1, and then we just have output. Then it prints, it's less than 8, it doubles it, and goes 2, and then it'll keep going until num is equal to 8. 2, 3, 4, 5, 6, 7, and 8. And these will all be doubled. So 4, 6, 8, 10, 12. Now I got to be careful as we get to the end. So num will become 6, and it'll print the 12. Then it becomes 7 and prints the 14. So we got the 14 right here. So it prints the 14, num is 7, becomes 8, goes back around, checks it. This is now false, it's equal to 8, so those two will not be done, and it'll go to the next line in the program. So like I've said a couple times, it's the last few values that you have to be very careful with. What happens at the very end? And if you're having trouble with all of it, just let me know and we can go over these. The next one. Num is 1 and the sum is 0. While num is less than 3, it'll print out num minus sum, which is 1. Then num is still less than 3, num is still less than 3, num is still less than 3. So this is an infinite loop. So if the test question says, what is the output? And one of the choices is infinite loop, that's what you should put, infinite loop. Num never got incremented. So to fix that, it should have said num plus plus. Now that would fix the infinite loop. So that is a possibility on the test. All right, now we get into nested loops. Just like we have nested ifs, we have nested loops. So here's the outside while, and here is the inside while. And we got to notice is this is in between them. It's inside the outside one, but it's not inside the inside one. It's in here, not in here. All right, well, what's happening? Num starts out with 1. I know this is the boring part. I know you'd rather be typing it up, but pay attention now. We don't program on our test. Keep that in mind. We do this on our test. So this is where you should be really focused. All right, not that you're not, but I just want to motivate you a little bit. All right, here we go. Num's 1. while num is less than 4. That's true. Sum is always set back to 0. That's important. That changes the output. Then we jump into here. While sum is less than 3, just print the sum. So it's going to go 1, 2, and I think it'll get to 3. Sum never changes on the inside. I'm doing the wrong one, aren't I? All right, I got to be careful. Speaking of focusing up. Sum changes. Sum goes 1, 2, and 3, and it's printing the sum. But does it print 0 right away? It does 0, 1, 2, and 3. Oh, does it print 3? It does not print 3. It becomes 3 and then becomes false. I got to be careful. Say again?
What no matter what? Print 0? Oh, no.
Yeah, it prints 0, yes.
Okay.
And I have that. It prints 0, 1, and 2. It will not print 3. It becomes 3, then this becomes false. Now, once that becomes false, num gets incremented by 1. So that becomes 2. And we do the whole thing over again because this gets reset back to 0. So it goes 0, 1, 2, and 3. But the output is 0, 1, and 2. When it hits 3, it's going to be false again. This becomes 3. And it does it all over again. This becomes 0, 1, 2, and 3. And this prints out 0, 1, and 2. But once this hits 4, we're at this line right here. Once this hits 4, it comes back up here, checks. It's equal to 4. And now the next line would be done if there's more to the program. So there it is. There's the output. Oh, and I guess it'd all be in a line. It's a print statement. So this would be 0, 1, 2, 0, 1, 2, 0, 1, 2. You got to be careful with prints and print lines too. Any questions on this? I mean, this is the test. We don't program on the test, ironically. You never program on the test in programming. Weird, huh? But that's the AP test too. You don't program at all. It's all written or multiple choice.